Mindsetters, welcome to today's Grade 11 Maths Show, proudly brought to you by Macmillan. I'm Katleho. Today we have a special revision lesson on number patterns and analytical geometry. We have selected highlights from lessons shown earlier in the term, just to help you guys revise all the work we did together in the first term. Remember, you can download all the notes you need on today's show on learnextra.co.za/live. Also guys, you can post any of your questions, your comments, your queries on our Facebook page, which is facebook.com/learnextra, as well as on Twitter, which is @learnextra. Now it's time to get back with today's lesson, guys. Take it away.
Now the best way to obviously get going with this is to show you guys an example, and this example comes from the Clever Keeping Maths Simple. We're looking at the grade 11 learner's book, and this is page 71, exercise 3.1, number 1C. Alright, so remember this is just revision of grade 10. Okay, they give us a general term, Tn is equal to 3n plus 2, and they say write down the first 8 terms of the sequence, and then they say write down the first difference. Now the first thing we need to do is to write down the first 8 terms if we hope to find the first difference. Okay, well actually you only need the first 3 terms, but in this case we're going to write down the first 8 terms. Remember, if you're looking for term 1, you simply replace the n with the term position that you're looking for. So if I'm looking for term 1, in place of n, I substitute 1. Okay, so term 1 is going to be 3 times 1 plus 2. So that's going to be 3 plus 2, which is 5. Okay, similarly, if I want term 2, I'm going to substitute 2 in place of n. So it's going to be 3 times 2 plus 2. So that's going to give me 6 plus 2, which is 8. Okay, term 3, we substitute 3 in place of n, and we get 3 times 3 plus 2. So that's going to give me 9. 9 plus 2 is 11. Term 4, and we go on all the way, guys. I'm not going to do all 8. I think you kind of get the picture now, but we do the same thing for term 4. We substitute 4 in place of n, and we get 3 times 4 is 12. 12 plus 2 is 14. Okay, and remember you'll carry on all the way like that till we get to term 8, because they asked us for the first 8 terms. Now, very importantly, in a linear number sequence, when you're dealing with an arithmetic sequence, once you have your first 3 terms, you can work out the common first difference, or the constant first difference. Okay, we only need 3 terms to work out the constant first difference. All you do to work out the difference, once again, you'll remember from last year, is we say D, the common difference, is equal to term 2 minus term 1. And that's also equal to, or you can say, term 3 minus term 2. And that's actually a good way for you to check, because term 2 minus term 1 must give you the same answer as term 3 minus term 2. So once again, if we look at our first 4 terms, we've got 5, 8, 11, and 14. Okay, remember I said you only need to work with 3 of those terms. So if I say term 2, which is 8, minus term 1, which is 5, I'm going to get 8 minus 5 gives me 3. And then term 3 minus term 2, so that's 11 minus 8. My answer is also 3. Similarly, if you said 14 minus 11, you'll also get 3. So what that means is that your constant difference, or your common difference, is 3 in this linear number pattern. And what you'll notice is if you look at the formula quickly, Tn equals 3n plus 2, do you see that that common difference of 3 is actually the value of A? Okay, which is what we're going to get to in a later example. Let's move on to the next question. So this is question 2. This comes from the Clever Keeping Math Simple Grade 11 Learner's Book. This is page 71, exercise 3.1, and this is number 2E. Okay, so the question reads, determine the next 2 terms of the sequence, and the sequence that they give us is 3, 10, 17, and 24. Now guys, if you want to determine the next 2 terms in the sequence, we need to figure out if it's linear. At this stage, the only sequence that you've learned about, because we're revising grade 10 work, is linear. Okay, so you've only learned about linear sequences, so this is going to be a linear sequence, but it won't be that easy as we go on. Okay, so we've got 3, 10, 17, and 24. Remember, to check that this is linear, we're going to say, is there a common difference? So term 3 minus term 2 must be equal to term 2 minus term 1, and this will give us our constant first difference if it is a linear sequence. So let's have a look. This is term 1, term 2, term 3, and term 4. So term 3 minus term 2, 17 minus 10, and 17 minus 10 is 7. Now let's have a look at term 2 minus term 1. So 10 minus 3, and that's also 7. So therefore, we have a constant first difference, which gives me the common difference between the terms of 7. So in other words, this is a linear number pattern. So if I want the next 2 terms of the sequence, all I've got to do is add on my constant first difference. So the next terms, remember this is term 4. Term 5 is going to be 24 plus your constant difference of 7. And 24 plus 7 is 31. And then for term 6, which will be the next term in the sequence, I'm going to say the previous term, which is 31, plus the common difference of 7, and I get 31 plus 7 is 38. What if I asked you to find the 100th term? Now, you can't keep on adding and adding and adding, going from term 6, add the next one, 7, 7, 7, 100 times. That's going to take forever. You'll be on one question through your whole exam. Okay, so we obviously need a neater, quicker way to work out any term in the sequence. In order to do that, that leads us to question 2, where they ask us to write down the general term Tn of the sequence. Remember that Tn, your general term, helps you to find any term in a sequence. Now in this case, in the case of the linear number patterns, our general term is given by Tn equals An plus B, where A is equivalent to the constant first difference. Okay, so A is the same as the constant first difference of the number pattern. Okay, here we've seen that the constant first difference is 7. So therefore, in our formula, Tn is going to be equal to 7n plus B. But remember, if you want the general term, you're also going to have to work out B. How do you work out B? We go back to the sequence, and we see we've got a whole list of numbers. Now, if you want to work out B, you need to use substitution that you learned in grade 9. Use any term in the sequence and use the value of that term to work out B. So, for example, and you can really use any term. I'm going to use term 1. Remember, term 1 here was 3. Okay, so I'm using term 1 has a value of 3. So therefore, in order to find B, I need to use substitution and say term 1, so replace n with 1 is equal to 3. But remember, our formula so far says Tn is equal to 7n plus b. So I'm going to say, well, term 1 is actually going to be equal to 7 times 1 plus b. But I also know that term 1 has a value of 3, so I make that equal to 3, and I solve for b. So I'm going to get 7 plus b is equal to 3. Therefore, b will be equal to, take your 7 to the right-hand side and just be careful with your signs. So 3 minus 7 will give me negative 4. Okay, so therefore, our formula now becomes Tn, or our general term, becomes Tn is equal to 7n minus 4. So that's the general term. Remember, the general term will help you to find any term in the sequence. So guys, what I always say to everyone is just check any term in the sequence and see if your formula works. So for example, let's check term 2. So I substitute 2 in place of n. 7 times 2 minus 4. So I get 14 minus 4 is 10. And then let's go back and have a look at the formula. Look at the sequence, and we see term 2 is in fact 10. So therefore, our formula is one that makes sense. It is one that's working with the sequence that we've got. So we have found the correct values for A and for B.
Okay guys, I hope you're really enjoying this revision session. If you are struggling and need help, remember to post on the page or send an email to helpdesk@learnextra.co.za. Now it's time for a break, so don't go away. We'll be right back. Welcome back, guys. I hope you are getting into the idea of revision. Please let us know how you are doing. I'd love to chat to you guys either on the page or on Twitter. Enough of the chat. Let's get back to our revision now.
We're going to look at another example. This comes from, again, the Clever Keeping Maths Simple. This is grade 11, Learner's Book, page 71, exercise 3.2, number 2. Okay. We are asked to write down the first 8 terms of the following sequence, and then we have to calculate the first and second difference. Okay, so the first 8 terms, let's have a look at that first. We've got Tn equals 3n squared plus 2. So if I want term 1, just as before, I'm going to substitute 1 in place of n. Remember here, because we're dealing with an n squared, straight away we know that this is quadratic. Okay, so this is a quadratic sequence. We've got 3 times 1 squared plus 2. All right, and that's going to give me 3 plus 2, which is 5. All right, for term 2, we substitute 2 in place of n. And we're going to get 3 times 2 squared plus 2. So that's going to give me 4 times 3 is 12. 12 plus 2, 14. Term 3, we replace n with 3 and we get 3 times 3 squared plus 2. So 3 squared is 9. 9 times 3, 27. 27 plus 2, 29. Okay, and guys, I hope that you at home are awake and you're checking my working out, because obviously I'm just doing it all in my head, and it's quite possible for me to have a little brain malfunction sometimes when I'm doing calculations without double checking them. Okay, 4 squared, 16. 16 times 3, 48 plus 2, is 50. And there's absolutely nothing wrong if you want to, and in fact maybe I should check some of these. There's absolutely nothing wrong with checking your answers if you're not feeling confident in them. So let's check term 3. We've got 3 times 9 plus 2. 29, yes, we are correct. And then 3 times 16 plus 2 is 50. Okay, so as I say, absolutely nothing wrong with just double checking. Then term 5 is going to be 3 times 5 squared plus 2. And this is going to give me 5 squared is 25. Once again, let's just check. It's going to be 25 times 3 plus 2. And that's going to give me 77. Okay, guys, you will continue in this way all the way to the 8th term. Okay, I'm not going to do all of them because I think you sort of get the idea so far. So our first 5 terms, we've got 5, 14, 29, 50, and 77. Obviously, the question asked you to go on for 8 terms, so you would continue substituting values for n all the way to 8. Okay, then we had to work out the first and second difference. So remember, and I'm just going to do this in a different color, to work out the first difference, I just say term 2 minus term 1, term 3 minus term 2, term 4 minus term 3, and so on. Okay. 14 minus 5 is going to give me 9. So that's the difference between those two. Okay? Then 29 minus 14, and let's see if my mental maths is right. 9 minus 4 is 5. 2 minus 1 is 1, so that's 15. Difference between 50 and 29. So we've got 10 minus 9 is 1, and 4 minus 2 is going to give me 2. So that's going to be 21. All right. And then obviously you can do the same with that. Once you've got 3 terms in your first difference, remember this is your first difference. Once you've got those 3 terms, in order to check and see what our second difference is and to check if it's common, we only need those 3. So I can straight away subtract these. Okay, so now we're working out the second difference. So we say 15 minus 9, and we get 6. And then 21 minus 15 is also 6. Okay, so we're happy because we've confirmed that, yes, it is a quadratic sequence. Obviously, it was a quadratic because they gave us the formula as 3n squared plus 2. But we've also confirmed it by showing that there's a constant second difference. And when there is a constant second difference, then your sequence is quadratic. So guys, we're going to carry on now with another example. And this comes from Clever Keeping Maths Simple, grade 11 learner's book, page 75, exercise 2.3, number 18. Okay, first question. Determine the next 2 terms of the sequence. All right, and the sequence they've given us is just a list of numbers. We don't know if it's quadratic. How do we determine if it's quadratic? Hopefully I've drilled it into everyone's head so many times now that it's just become, oh, what a boring question. It's quadratic if you have a constant second difference. Okay, so if you've got your list of numbers, you want to tell if it's quadratic, we need to find the second difference. And then once we know it's quadratic, then we can find the next 2 terms. Okay, so let's get going. So we say minus 1 minus minus 4. Guys, when you do this, be careful. I'm just going to do it on the side here. Just remember with your signs, you've got to be careful. It's minus 1 minus minus 4. Use brackets so that you don't confuse your signs here. So it's going to become minus 1 plus 4, which is just going to give us 3. Okay, so my first term of my first difference is 3. Then I'm going to say 4 minus minus 1. Again, be careful with your signs. It's going to become 4 plus 1, which is 5. And then we say 11 minus 4, and that gives me 7. Okay, so that's my line of first differences. I want the next row to be my constant second difference. So I say 5 minus 3, I get 2. 7 minus 5, I get 2. Now, you guys would have noticed in both the first examples we've done, the constant second difference happens to be 2. That's not always the case. Just so happens in these examples that we've chosen that your second difference happens to be 2. Okay, so don't think that that second difference is always going to be 2. It doesn't work like that. It depends on the terms you're given. All right, so here we've got our constant second difference of 2. Okay, because we have a constant second difference, that tells us that it is quadratic. All right, so how do I get the next two terms in this sequence? Okay, it's a little bit tricky. We've got to work backwards here, or forwards, depending on which way you're looking at it. Okay, so I want to know what this is. I want to know what that is. We don't have the formula. So how do we do it? Well, we can say we know that there's a constant second difference of 2. So the next term in the first difference must be 9. How did I get that? Well, 7 plus 2 gives me 9. And then the next term in the first difference must be 9 plus 2, which is 11. Because remember here, you've got a constant second difference going all the way of 2. So although I don't know what these are, all I've got to do is just add. Because I know my constant difference is 2. So I say 7 plus 2, I get 9. 9 plus 2, I get 11. If I wanted the next term in the first difference, I'd say 11 plus 2. But we don't need it. Okay. Guys, remember, these are not your terms in the sequence. This is your terms in your first difference. Okay, we still need to find out what is the value of term 5 and term 6. Okay, now have a look at how these other terms that were given were worked out. In order to get 4, which is my third term, I went minus 1 plus 5. Minus 1 plus 5 gave me 4. When I went to term 4, which is 11, in order to get there, I would have had to say 4 plus 7, and that gives me 11. So if I want term 5, I'm going to say 11, which is term 4, plus my first difference, which is 9, and that's going to give me 20. Okay, so that's term 5. Okay, so to get term 5, you simply say term 4 plus your term in your first difference. So we said term 4 plus the fourth term in my first difference, and that was 9, and I get 20. Okay, so term 6 is going to be similar. All right, we know that this term, term 5, is now 20. I want to find out what the next one is going to be. So remember, I said 11 plus 9 gives me 20. The next term, term 6, is going to be 20 plus 11. And that's going to give us 31. All right, so here we had to say term 5 plus the fifth term in the first difference. Okay, so guys, with this it can be quite tricky. Now imagine if you were asked to find the 20th term and you've just got this sequence of numbers. Very tough to keep on doing, okay, find the first term or find the term in the first difference, then add it to the term before. It can get quite confusing and sometimes you can forget what you've done and that kind of thing. So we need to be able to find the general term, because remember, once you have the general term, then you can work out any term in the sequence. We don't have to go back and now add and add and add and all of that. Okay. So without further ado, I'm going to get stuck straight into the example because it is quite a long one. All right, so guys, when we left off, what we were doing is we were going to look for the general term of this sequence, minus 4, minus 1, 4, and 11. We saw that it was quadratic. We saw that the constant difference in this case was 2. Remember, the constant difference tells us that it is quadratic. Okay. And we worked out that, well, I worked out during the break that your A, remember A is your second difference divided by 2. That is always the case. In this case, we got our second difference is 2. So 2 divided by 2 is 1. So therefore, my equation now becomes wherever there is, in the first case, we've got Tn is equal to n squared plus bn plus c. How did I get that? All I simply did was I replaced the a with 1. Okay, so it just becomes n squared plus bn plus c. Now, when we do the simultaneous equations, we've got to use terms that are in the sequence to help us find b and c. So I knew that term 1 is minus 4. So therefore, in place of n, I put in 1. And I say term 1 is equal to minus 4. And this will give me one equation that I can use to solve simultaneously for b and c. All right, so this is going to become 1 plus b plus c is minus 4. Therefore, b plus c is minus 5. And b is equal to minus 5 minus c, which we call equation 1. Then we're going to use the fact that term 2 is equal to minus 1 to give us the second equation. So wherever there is an n, I'm going to put in 2. Okay, so I'm going to get 2 squared plus b times 2 plus c is equal to minus 1. Okay, so this is going to become 4 plus 2b plus c is equal to minus 1. Therefore, 2b plus c is equal to minus 5. All right, we can then call this equation 2. Remember, we're using the method of substitution with simultaneous equation. So therefore, if b is equal to minus 5 minus c from equation 1, I'm going to substitute equation 1 into equation 2. All right, what that means is where there's a b, I put in minus 5 minus c. So it's 2 times minus 5 minus c plus c is equal to minus 5. All right, so then I'm going to times the 2 in, so I get minus 10 minus 2c plus c is equal to minus 5. Minus 2c plus c is just negative c. And negative 5 plus 10 is going to give me plus 5. So therefore, c dividing both sides by negative 1. So we're going to get c is equal to negative 5. All right, but remember, we're not done because we still need the value of b. And we know that b is equal to minus 5 minus c. This was equation 1, remember? So therefore, if I want the value of b, I simply substitute the value of c into equation 1. And I get b is equal to minus 5 plus 5, which is 0. So my equation now becomes Tn is equal to n squared plus 0n minus 5. But guys, we don't ever write 0n like that, do we? No, because that whole term is just going to cancel out to give us 0. So my equation is actually n squared minus 5. Okay, so that is the general term. Sorry, not your equation. Your general term is n squared minus 5. Now, you can use that to find any term in the sequence. And in fact, what you should do is once you've got the general term, just check and see if it works. Okay, so for example, we know that term 1 was minus 4. If I put 1 in place of n, I'm going to get 1 squared minus 5 which is -4. So therefore it works. Term 1 is -4. You can go on and check with term 2, term 3, and so on until you're completely satisfied that that is the general term. But what you need to do in a test or an exam or anything like that, always just check at least one of your terms. Okay.
Now it's time for a break, so don't go away and we'll be right back. Welcome back, Mindsetters. Today we are doing revision. Even though we are selecting highlights from previous shows, you can still follow me on Twitter @LearnExtra or post or comment on our Facebook page, facebook.com/LearnExtra. Right now, let's do some more revision.
Right, I said that I was going to go and look at some questions. We'll start off the next question before we go on to the break. So let's look at the information that's given. Again, we're taking it from the textbook, page 104, and this time around we're doing question 10. The diagram that is found has got points L is 3, 4, M is -3, 0, and N is 5, -2. They've also given us that P is the midpoint. Look very carefully how that is marked on the picture. If P is the midpoint of a line segment, then the segment from P to M is going to be the same as the segment from P to L, so that gets marked on the diagram straight away. And also LN cuts the x-axis at E, and they've actually defined for us that the inclination from 0 degrees all the way to the line, they've defined that as theta, is the inclination of that line LN. So now some straightforward questions. What is the length of MN? And you should try and beat me to getting to that formula. What is the formula for the distance of a line segment? And I don't like to use that big square root because I'm writing square roots forever. So I like to just say the square of MN, if you just look at that squared, would be the change in the y values and the change in the x values. So it's 5 plus 3 squared. So it's 5 plus 3 squared. And then you add on the difference in the y's, which is 0 plus 2 squared. And you just simplify that in the squared form. So that would give me 64 plus 4, which is 68. So MN is 68. And then your calculators are very, very bright, and they'll be able to give you that in simplest third form. So MN would just be the square root of 68. Can you see now my square root is just tiny? It's little. I don't have to have those massive square roots coming along. And that gives me 2 root 17. So that is the distance of MN.
There are a couple of questions that Dina has to go over before we get to more serious stuff. The first one is from Lucky saying, is inclination always on the positive x-axis?
It's a very good question. How do we define it? What is the laws that govern inclination? And yes, it's always measured. If this was my positive x-axis, it's always measured from that, and it goes inclined in an anti-clockwise direction. So like you measure an angle in trigonometry, you always start measuring an angle into the quadrants by starting on the 0 degrees. So that's why we're measuring it on a positive x-axis, because that's our 0 degree line, and that's where we will begin to rotate from. So yes, inclination always gets measured in that way. So inclination would not be measured from the negative x-axis, because we don't measure angles like that. So basically the way you use an angle in trigonometry is the way that we are measuring an angle here as well, always from the positive x-axis. That's correct.
Well said. And the last one for now from Lakim Msibi saying, I really don't understand, where does that 135 come from?
Okay, the 135, and I just, for the other viewers who may have just tuned in, I want to go back to that angle earlier. Let's see where, oh, there we go. Where tan of T1 was -1, where do I get 135 from? Remember that if a tan ratio is negative, your calculator is programmed not to give you the second quadrant angle and not to give you the positive fourth quadrant angle. Your calculator has been designed specifically to give you the fourth quadrant angle, but the negative angle. Okay, so just in terms of a trig revision question, let's just go here. So if we have if we have this angle over here to calculate, then this is an obtuse angle. But if tan theta is equal to -1, your calculator, what does it give us? It gives us -45. Where is that angle? We need to understand the calculator. Where is this angle? So the calculator is going to give us this angle over here. That is -45. Okay. Now, through a process, and I think I've made it bigger than -45, but nevertheless, you'll understand that's -45. So every single ratio that's negative, tan has been programmed to give you that angle in that quadrant. What we're now saying is if we take this line across, then these angles are vertically opposite, so that's also -45, that angle there. So to get this left over here, to get this angle here, we would say that it's 180 take away this 45 degrees, so 180 take away 45 will give you the 135. So to get the obtuse angle, I always have to take 180 minus that given angle in the fourth quadrant in order to get the obtuse angle. So that's just a process of being able to find obtuse angles because the calculator hasn't been programmed for that. Okay. Let's just see if this is where we were. We were going to work out the length of MN. Yes, we did that. And then we were going to work out the midpoint. Okay, P is the midpoint. So how would you work out the midpoint? Now, the midpoint's the easiest part because we have the sum of the coordinates divided by 0, sum of coordinates divided by 0. 3 minus 3 is 0, divided by 2 is just 0. So this point over here is 0. And the sum of the x's is 4 plus 0 is 4, divided by 2 is 2. So midpoint, sum of coordinates divided by 2, both in the x and in the y. Okay, so that would be the midpoint. Equation of Ln. There's Ln. Let's just color that in a different color. There's Ln. And what's its equation? And again, because you've got 2 points, what can you work out? We can work out its gradient. So gradient of Ln is equal to the change in y, 4 minus 2 is 6, and the change in x, 3 minus 5 is -2. So the gradient of that line is -3. That is great, because now the equation of the line, I can use any of these points. Remember earlier on I gave you that equation, y minus a y value, and let's choose this point. I think I like that point. It doesn't matter which one you choose. I'm opting for that. So we've got 4 equals the gradient multiplied by x minus the x of a, which is x minus 3. So we've got y equals -3x. I'm going to multiply that in. I get a 9. And a 9 plus a 4 is a plus 13. Okay, so that's Ln. I can see it's quite a steep line. So I'm saying it's going through plus 13. It kind of is reasonable for that to happen. Okay, what question do you think is going to be asked next if I've worked out the gradient of Ln? Can you see that inclination theta, as somebody said earlier, is it always measured from the positive x-axis? Yes, it is. Always from 0 degrees, measured as in trigonometry. So the value of theta correct to 1 decimal place. So let's fill that in here. We would have that the tangent of the inclination is equal to the gradient of the line, which in this case we worked out as -3. Now, the tan ratio is negative. What are you expecting to happen? The calculator has been programmed to give you a negative angle, fourth quadrant angle. We are going to do some geometry, vertically opposite angles, so therefore your obtuse angle is 180 minus that calculator angle that you've been given. And so theta will then be obtuse, and my obtuse angle is going to be, we're going to use our magic machine to work out that we need a -3, and that gives us -71. Remember, that is the fourth quadrant angle. I need to add on 180 to bring me back to obtuse, so it's 108,4. 108,4. Okay. So a reminder that your negative 71 programmed calculator always gives you a fourth quadrant angle. I can't get away from that. It hasn't been programmed in another way. And to get to the obtuse, I add on 180 degrees. Right, and then the inclination of ML correct to one decimal place. Where's ML? Where's ML? There's ML. So we've got this line here, ML. So the inclination of that we could actually call M1. Okay, so let's work with a gradient of ML. Change in y over change in x. Change in y, 4. Change in x, 6. So the gradient is 2/3. So magic machine to help us work out what the gradient is. I mean what the angle is, the inclination, is of 2 divided by 3. And we get 33,7. So that's 33,7. So that's the inclination. Okay. It is acute, so it's not giving us that negative. And then finally, we can work with the size of MLN. So the size of MLN, okay, this does not lie on the x-axis, but notice very carefully, if we look around, we did work this out earlier as 108,4. So let's fill it in, 108,4, which means again we've got that exterior angle of a triangle, minus 108,4. Minus 108.4, and what do we get? 74,7. So this angle over here is 74,7, working with the exterior angle of a triangle. Okay, so really inclinations as a review can either be acute or obtuse. Because the connection between the inclination and trig is that tan of theta is equal to the gradient, we're going to have some tan ratios are negative, some tan ratios are positive, and if they are negative, the calculator is going to give you a fourth quadrant angle, or a fourth quadrant angle, which you need to convert into an obtuse angle.
Guys, we've come to the end of today's show. Thank you so much to Macmillan for making this wonderful show possible. And thank you to you guys for joining me and participating fully in today's revision lesson. Remember to visit our website, guys, for all your notes, all the videos that you need to watch from earlier on in the term. Our website is learnextra.co.za/live. Guys, if you're stuck or you need to ask any questions, please send an email to helpdesk@learnextra.co.za and let us know exactly where you're stuck so that we can help you even more. Don't forget to look out for more news on Library Month on our Facebook page as well as on our website. And guys, remember to join us for Easter Revision too. Bye guys.